Question 1. Which side of the triangle below is the hypotenuse? The longest side of a triangle, the right-angled triangle, is known as the hypotenuse. So the longest side we have here can be named for the letters that are on either end of it. In this case, the hypotenuse is RT. Question 2. Which is the correct Pythagoras theorem statement for the triangle below? For any right-angled triangle, the square on the hypotenuse equals the sum of the squares on the other two sides. So the square on the hypotenuse, now the hypotenuse is U, and the other two sides are D and M. So the square on the hypotenuse, the square of U, equals the sum of the two squares on the other two sides. So U squared equals M squared plus D squared is the correct Pythagoras theorem statement for this triangle. Question 3. Which is the correct Pythagoras' theorem statement for the triangle below? For any right-angled triangle, the square on the hypotenuse equals the sum of the squares on the other two sides. So the hypotenuse here can be named as PR or RP. And so we'll start with the square of that as the first part of our Pythagoras' theorem statement. So RP or PR, if you'll have a look through the question, we need to square that. So the bottom option, option D, is the only one that squares PR as the starting point. And we'll just check the rest of it. PQ is one of the shorter sides and it's getting squared, and QR is the other shorter side and it's getting squared. So I'm happy with D as the correct option there. Question 4. Find the length of the hypotenuse below. For any right-angled triangle, the square on the hypotenuse equals the sum of the squares on the other two sides. Okay, so the square on the hypotenuse is x squared equals the sum of the squares on the other two sides. So 3 squared plus 4 squared completes the Pythagoras theorem statement there. So x squared on the left-hand side equals 3 squared, which is 9, plus 4 squared, which is 16. We'll just simplify that or calculate that right-hand side, end up with x squared equals 25. We need x as the length, so we need to undo the square, which is needing a square root both sides. On the left-hand side, that'll give us our x, and on the right-hand side, that will give us a square root of 25. You can type that into our calculator or think of something smaller. When squared, that gets 25. Final answer, x equals 5 for the length of the hypotenuse in that triangle. Question 5. Find the length of the hypotenuse below. Give your answer correct to 1 decimal place. For any right-angled triangle, the square on the hypotenuse equals the sum of the squares on the other two sides. So the square on the hypotenuse this time is y squared, and the sum of the squares on the other two sides gives us 5 squared plus 7 squared to complete our Pythagoras statement here. So y squared on the left side equals 5 squared, which is 25, plus 7 squared, or 7 times 7 makes 49. Let's simplify that right-hand side and get y squared equals a total of 74. We need y on its own for the length of the hypotenuse, so we need to square root both sides. The left-hand side, that leaves us with y, and the right-hand side of root 74. Now we need to put that into our calculator and round carefully to 1 decimal place. Gives us 8.6 to 1 decimal place for the length of the hypotenuse. Question 6. Find the length of the hypotenuse below. Give your answer correct to 2 decimal places. For any right-angled triangle, the sum of the squares on the hypotenuse equals the sum of the square on the hypotenuse equals the sum of the squares on the other 2 sides. So the square on the hypotenuse here is m squared, and that equals the sum of the squares on the other 2 sides. The other 2 sides are 7 and 12, so we have 7 squared plus 12 squared for our right-hand side there. So let's go with that. Let's process that. 7 squared is 49. 12 squared is 144. When we add those two together, we get 193 on that right-hand side. We need to square root both sides because we're interested in finding m on its own here. So we'll square root both sides. M equals the square root of 193. We need to process that through our calculator and round it carefully to 2 decimal places. You should get m equals 13.89 as the length of the hypotenuse. Question 7. Find the length of the hypotenuse below. Leave your answer in exact form. For any right-angled triangle, a square on the hypotenuse equals the sum of the squares on the other 2 sides. Square on the hypotenuse in this question is a p squared, and the other 2 sides are 5 and 4, so we'll have 4 squared plus 5 squared. P squared equals 4 squared, makes 4 times 4 is 16, and 5 squared, 5 times 5 is 25. We'll just join that on the right hand side to make it a bit simpler. P squared is 41. When we square root both sides to get P on its own, we'll get P equals root 41. Now exact form requires us to leave it with the square root around the number and not process it any further. So leave your answer with the square root on it when it says to leave your answer in exact form. Question 8. Find the value of the shorter side, g, below. Leave your answer as a whole number. As usual, for any right-angled triangle, the square on the hypotenuse equals the sum of the squares on the other 2 sides. So the hypotenuse here is 13. We're going to start off with the g here. And because we're finding a shorter side, our Pythagoras statement is going to have a minus between the 2 number sections. It's going to be g squared equals the bigger number squared minus the smaller number squared. That's how I like to set out my Pythagoras questions when they're trying to find a shorter side. It's the big number squared minus the smaller number squared. G squared on the left hand side, 13 times 13, I'm here to tell you is 169. You can check me on the calculator. And minus 12 times 12, which is 144. So we'll simplify that right hand side and we end up with g squared equals 25. And you know the drill, we need to get g on its own. How do we undo a square? We do the opposite to both sides, which is square rooting. Left hand side ends up being g, right hand side ends up being square root of 25. And the square root of 25 gives us 5. So finding a shorter side, you need a minus in your Pythagoras statement. It's big number minus smaller number. Question 9. Find the value of the shorter side, w, below, giving your answer correct to 1 decimal place. For any right-angled triangle, the square on the hypotenuse equals the sum of the squares on the other 2 sides. So we're finding a shorter side here. So we're going to start off with w squared, and we'll have the bigger number, 17.3 squared, minus this time the smaller number, 8.6 squared. So that's the way I like to set up my Pythagoras statement when I'm finding a shorter side. This is a calculator job here, I think, for you if you're doing it quickly. 17.3 times 17.3, we get 299.29, trust me. And 8.6 squared, 73.96. And we'll be simplifying that. W squared ends up being 225.33. To get W on its own, which is what we want, we'll square root both sides. So in your calculator, we'll get a final answer of 15.0 because it was asking for 1 decimal place. So the length of W, the shorter side there, is 15.0. Question 10. Find the value of the shorter side K below. Give your answer correct to 2 decimal places. That's the drill. For any right angle triangle, a square on the hypotenuse equals the sum of the squares on the other 2 sides. That's what the question or our solution will be based on here. We're finding a shorter side, so I like to start with the letter squared equals the bigger number, in this case 23.56 squared, minus the smaller number, 12.4 squared. So processing that on our calculator, we'll get that big number minus that pretty big number. When we calculate that out on the right hand side, we'll end up with that number, 401-ish, and we'll square root both sides to get K on its own. So it's just a matter of processing and simplifying there. Square root of that ends up being 20.03. Now that was to 2 decimal places, so we'll need to round it carefully. And I like to check in these questions whether it makes sense or not. Because the hypotenuse there is the longest side, 23.56, and one of the shorter sides is 12.4, I'm expecting an answer that's somewhere between, or somewhere around the shorter side, but definitely not larger than 23.56. So if you get a larger number for your answer here, you've done something wrong. So I just like to see if it makes sense in my mind, whether it should be smaller than the hypotenuse, which it always should be if you're finding a shorter side. Anyway, so we set up those Pythagoras questions there with a minus in between the squared numbers when we're finding a shorter side.